Good morning. Today I am going to explain expression for intensity of electric field at any point on the axis of an electric dipole. Okay, so this is one of the important topic in electrostatistics, and before going to talk about this topic, first of all we should know what is electric dipole and what is electric dipole moment. Okay, so here the chapter name is what? That is electrostatistics. Electrostatistics means a branch of physics which deals with the charges which are at rest position. Now what is electric dipole? Electric dipole is nothing but it's a simple arrangement of two charges with some distance. Okay, here the minus q and plus q charges are separated by a distance 2l. Here the center of these charges is O. Here to here distance is L and here to here distance is L. The total distance between the two charges is 2L. So simple the arrangement of 2 points with some definite distance is called the electric dipole. Now what about electric dipole moment? So electric dipole moment is nothing but it's a product of one of the magnitude of one of the charge and the distance between the two charges. Okay, so it's a product of magnitude of plus q or minus q. You can take magnitude of one of the charge and the distance between the two charges. So that is two charges distance is 2l. So that can be written as p is equal to q into 2l, that is measuring in centimeters, and this is known as the electric dipole moment. Now come to the point, that is our aim is we have to find out the intensity of electric field at any point on the axis of an electric dipole. So first of all we have to consider AB is an electric dipole. So axis, along the axis is this axis. Okay, so let us suppose P is a point where we have to calculate the electric field. Okay, so for that purpose first of all we have to consider, let us consider an electric dipole AB with the center O. Okay, let E1 be the intensity of the electric field due to the plus q charge and is given by. So now we have to calculate the intensity at a point P due to the plus q charge and due to the minus q charge. So first of all we have to calculate the intensity at a point P due to the plus q charge. We know that intensity of electric field is can be given as E1 is equal to q by 4 pi epsilon naught r square. We know the general definition for electric field intensity. Here q by 4 pi epsilon naught r is nothing but here plus q charge, intensity at a point due to the plus q charge. So the distance between this plus q charge to the P is BP. So BP value is how much? That is R minus L. Okay, so from there to there this is R and this can be written as R minus L. Okay, so here this can be written q by 4 pi epsilon naught R minus L whole square. Let us take that is equation number 1. Now intensity E2 be the intensity of electric field at point P due to minus q charge. So I wrote this, let E2 be the intensity of electric field due to minus q charge is given by. So that can be given as E2 is equal to q by 4 pi epsilon naught R square. R square is here what? That is A to P, intensity due to minus q charge at point P. So that is the distance between those two is A to P. So A to P distance is what? That is P to O is how much? R, and O to A is L. It means R plus L. So A to P distance can be written as R plus L. So I can write AP whole square is can be written as R plus L whole square. So let us take this is equation number 2. Now we have to calculate the resultant intensity or resultant electric field intensity at a point P due to plus Q minus Q. So that's why therefore the resultant intensity of the electric field E can be written as E1 minus E2. Why E1? Because E1 is greater than E2 and they are along the same line but in opposite direction. Okay, so both the charges are one is minus Q and one is plus Q. Both are in the same line but in opposite direction. That's why we can write resultant intensity will be E1 minus E2. So E1 value is, we know, that is Q by 4 pi epsilon naught R minus L whole square. We calculated this one here. And next E2 value is 4 pi epsilon naught R plus L whole square. Okay, so now we can take the LCM of this one. This LCM of this can be written as R square minus L square whole square. So this can be written as R plus L whole square minus R minus L whole square. So and again this can be written as Q by 4 pi epsilon naught. So if you simplify this one, this is in the form of A plus B whole square and this is in the form of A minus B whole square. So if you simplify this equation, then we will get 4RL by R square minus L square whole square. Okay. Now here E can be written as 2. This total equation is we are writing in the form of, this is 4RL. I am writing 2 separately. 2LQ into 2R by 4 pi epsilon naught R square minus L square whole square. Okay. So we know that R is greater than L. Here I can consider this R is very large compared to the small L. So that's why that time I can neglect the L value. Okay. So that's why R is greater than L. So in this equation we are neglecting the L. So that's why we are getting only R to the power of 4 only. Okay. And next here 2LQ. 2LQ is nothing but an electric dipole moment. So already I told you that is electric dipole moment is nothing but it's a product of one of the charge and the distance between the two charges. Okay. So here this 2LQ is replaced by 2P. P. Then this can be written as E is equal to P by 4 pi epsilon naught dot 2R by R to the power of 4. Okay, you are neglecting the L square or L to the power of 4 is we are neglecting. L is very small. If you compare to L to the power of 4 means very still smaller. So that's why we are neglecting. So next E is equal to here 2P by 4 pi epsilon naught R cube, and this is the resultant intensity at a point P along the axis of the dipole, and this is measuring in newtons per coulomb. Thank you. For more videos, subscribe my channel Physics.